Alright everybody, so today's new lesson is on adding and subtracting like fractions. That's as opposed to unlike fractions, so meaning today everything's going to have common denominators for like fractions. That's good. It says rules. Number one, we must have common denominators. We absolutely have to have common denominators when we're adding and subtracting fractions. So the denominators have to be the same. And since we're talking about like fractions today, that's going to be the case every time, so that's good. Rule number two, if they are common denominators, then we do step two, which is simply add or subtract the numerators. Rule number three, the denominator will stay the same. And this is the part we just got to get used to. Number four, always, always, always simplify. We say always 3 times because make sure it's important enough for us. Got to always simplify. Okay, let's do an example one. So step number one on the previous page said that our denominators had to be the same. Okay, well, since we're talking about like fractions today, that's the case. And if they're the same, well, then that denominator is just going to come along for the ride. Since they're both 100, it's going to stay 100. Okay, so common denominators. Step two says simply add or subtract the numerators. So since it's an adding problem, I'm going to add the two numerators. 77 plus 9 is going to give me 86. Step three, the denominator will stay the same. So we already did that. It's 100. And step four is always, always, always simplify. So I look at this number and say, well, now I have to simplify it. So use your divisibility rules. And since I know that both numbers are even, I'm going to divide them by 2 here. So when I reduce, I'm just going to show this work here. I'm going to divide by 2. 86 divided by 2 gives me 43. 100 divided by 2 is 50. And that is reduced. It's in simplest form. So we get 43 out of 50. Okay, so again, common denominators, add or subtract the numerators, denominator stays the same, simplify. Alright, so example 2, I got 2 problems here, A and B. I'll do the first one for us, and then I'll let you guys do part B. What I look at here when I'm doing part A is I see that this is a negative 4/7, and this 2/7 is also a negative, because remember the sign of a number is always what's in front of it. So when I look at these two numbers, I'm really looking at a negative 4/7 and a negative 2/7. And remember, I really don't care that it's supposed to mean subtraction in the middle. Okay, what I care about is the signs of these numbers, because remember we said if the signs are the same, okay, if the signs are the same, which they are in this problem, that we're supposed to add the two things together. So we're really doing this. We're really doing negative 4 plus negative 2, because the signs are both negative. That tells me to add. Negative 4 plus negative 2 is negative 6. And just like our rules say that since the common denominators are 7, that just comes along for the ride, and I get a negative 6/7. Okay? So again, even though we're working with fractions, we got to remember our integer rules about if the signs are the same, we add. If the signs are different, I subtract. Okay? Part B, I'm going to go ahead and let you guys try it on your own. Being very careful that you notice that this negative and this negative. Okay? So you want to go ahead and switch that right away. So pause the video, give it a try. Okay, and we're back. So what I would do here, as soon as I see that negative and negative, we got to get used to that. That means it's going to be the two negatives make it positive. So the 1/10 stays the same. The minus negative 3/3 becomes plus 3/10. I think I said 3/3. It's 3/10. Okay, 1/10 minus a negative 3/10 becomes 1/10 plus 3/10 because the two negatives change into a positive. Okay, again, since they're both positive, my rules say to add them together. Numerators, 1 plus 3 is 4. Denominators are both 10, so they stay the same. And it comes along for the ride to get 10 again. And then always reduce 4/10. I can now reduce that by dividing by 2. And I end up getting 2/5. Okay, so really the big things today, guys, are common denominators. And then the signs of the number are actually going to tell you if you're adding or if you're subtracting. Okay, example 3 here. So I got 2 problems here, A and B. Again, I'll do part A, and then I'll let you do part B. So part A, when we're dealing with mixed numbers, now mixed numbers are okay when adding and subtracting. So I'm going to write this down. Mixed numbers are okay. Okay, that's awesome, because for multiplying and dividing, they're not okay. And then what I have to do here is this, is we're going to follow these instructions where it's the fraction part first. Okay, so if I do the fraction parts here, I'm doing 5/9 plus 2/7. So the numerators, 5 plus 7 gives me 12/9, because the 9's a common denominator. It just comes along for the ride. So a fraction part first, and then you do the whole number part second. Okay? So now the whole numbers is I have a 5 and a 2. They're both positive, so same sign, so I add. 5 plus 2 gives me 7/9. Now what you should realize here is that when I get my answer of 7 and 12/9, that this 12/9 is an improper fraction. Okay, and it's not okay to have an improper fraction as your answer. So what we have to do is change that, and I'm just going to do this down below part A here, where if I take that fraction 12/9 and tried to change that, I would say, well, how many times does 9 go into 12? Well, it goes into there once, so that gives me 9. I need an extra 3 to get to 12, and then my denominator still stays the same. Then what we realize is, okay, the 12/9 becomes 1 and 3/9. So this whole number 1, has to be added on to the 7 that you already have there, giving you 8. Okay, and then instead of 12/9, we write what we had left over, which was the 3/9. Of course, we always simplify, so I can reduce the 3/9 to get 8 and 1/3 as my final answer. So make sure that you're simplifying those improper fractions at the end there. Okay, you guys go ahead and try part B. Okay. So what we're going to do here, if you're back, is I notice that this is a negative 10 and 6/13. This is a negative 6 and 8/13. So that tells me that the signs are the same. And if the signs are the same, that's going to tell me to add these two things. And if I'm going to add these two things, again, same rules as before, is that you should be doing the fraction parts first. So if I do the 6/13 and the 8/13, well, 6 plus 8 gives me 14/13 for my fraction part. Okay, now the whole number part's negative 10 plus negative 6 gives me negative 16. So you get a negative 16 and 14/13. Now I want us to be very careful. Okay, what I want us to do, I'm going to point out this negative. Because that's a negative 16 and 14/13, I know my final answer is going to be negative. Other than that, I really kind of want to forget about it for right now when I do 16 and 14/13. So what you're going to say is 13 goes into 14 once, but that 1 gets added on to the 16 and makes it a 17. Okay, and then you'd have 1/13 left over. But you almost got to forget about the negative for a second when you add that 1 on. You don't want to add 1 on to negative 16 and get a negative 15. That's not going to work. Okay, you just have to know that since it was a negative, at the end, you put that negative on there. Okay, so you got to forget about it for a second. Okay, here we go. So fraction problems. Fraction problems with variables. We haven't done variables yet here. Okay, again, we have common denominators. So that tells me just to deal with the numerators then. Okay, so on top I have 3a plus 5a. Signs are the same, so I add. 3a plus 5a is 8a. Denominators are 20. That comes along for the right. It's still 20. But what I realize is that the 8 and the 20, I can actually reduce those. Okay, I can divide both of them by 4. So 8 divided by 4 is 2. 20 divided by 4 is 5. And this is just simplifying things just like we did before. So we end up getting 2a over 5 because the 8/20ths becomes 2/5. Okay, you guys go ahead, pause the video, last problem, try part B. Okay, you're back. Now, again, the first thing that comes to my mind right here that I see is those two negatives. So I get 2 negatives are going to change into a positive. So I'm going to rewrite this. Negative 8 over 3b plus 2 over 3b. Okay, well, the denominators are exactly the same, so that's just going to stay the same. It's going to stay 3b, and then what we have to do here is the negative 8 plus the 2, which is a negative 6. Okay, the 6 and 3 can both be divided by 3 to get 2 and 1. Okay, and then I just rewrite my final answer. I've got a negative 2 on top, and I've got a b on bottom. So you end up getting negative 2 over b as your final answer. That's our lesson for today.